Good afternoon, everyone. Thank you for coming for one of the last sessions today. All right, so my name is Skrypnyk. Stuart, Rowlands. We are going to talk today about migrations at scale in scope of GovCMS 2.0. Just a little bit about myself. Doing solution architecture for 10 years and doing like Drupal development experience and also DevOps engineer.
Hey guys, Stuart Rowlands. I've been involved with GovCMS since pretty much day one. Before that, been in web development since IE1 and BBSs before that. Bit of DevOps, app and web development. So yeah, all around tech junkie is me.
Cool. About GovCMS. So for those of you who don't know what GovCMS is, and this is going to be very short. Sorry?
This is a test.
Yeah. It's first of all kind of Drupal 7, Drupal 8 distributions, but also it's a website hosting for the government agencies. So provide those two things, and it's a SaaS and PaaS. Has SaaS and PaaS models. With the SaaS model allows you to work only with the theme and list of pre-approved modules, while the PaaS allows to fully customize modules and themes, so basically hosting in the cloud. Currently it is hosted on AWS cluster controlled by Lagoon, which is amazing.io product that's backed up by Red Hat's OpenShift, which is a distribution of Kubernetes, which has been mentioned multiple times during this couple of last days. Our project was very interesting, and the goal was to migrate more than 100 sites to this new developed platform, and make sure that the community will be able to contribute to the GovCMS distribution in the easy way. We already had a good experience with enough experience with using Amazy.io's Lagoon with DPC project, and that was a good segue for us to build a platform for GovCMS. But that was not that simple. So we started to from requirements analysis. Basically, we knew that we need to migrate all SaaS sites. 108 of them, and so I don't know whether you can see this, but it says repeatable migrations was one of the major requirement. Second one was that we actually have to Lagoonize each site. Lagoonize means that we need to make sure that the site which runs on the GovCMS 1.0, which was hosted on Acquia, that it can run on Lagoon. Kind of drill down a little bit on these requirements. So for repeatable migrations, we needed a job runner with a UI. We needed some kind of a scripting language to allow custom and repeatable steps. We also needed to make sure the migration are idempotent, so we can rerun them as many times as we want. Because there was so many files, so many sites, we needed to make sure that we use some kind of a generic configuration for all of them, but at the same time, if we did require some kind of per site configuration adjustment, we had a mechanism to do that. So quite a lot of requirements, I would say. So there are solutions so for this job runner with UI and scripting language, we picked AWX, which is an Ansible-based job runner. I'm gonna talk about it a bit later. And for the unified configuration, we used this unified scaffolding repository. There was another repository that basically every one of those 108 sites that we were migrating was using the scaffolding to populate some of the files. I'm gonna go over it a little bit more. To Lagoonize each site, we need to provide some Lagoon configuration and actually Dockerize the site. So the site should have run on the Docker, using the Docker, for which we had to create Docker images for which we had to make sure that the images are quite stable and the community could benefit from those images, and that the images can be published and publicly available for everyone. So yeah, we had to build, we had to open the images through GitHub to make it public, and also for stability, we had to provide continuous integration with testing. So all the GovCMS images are actually tested, and they're published to Docker Hub automatically as a latest releases. And there's also ability to publish them manually once they are stable and ready for release. And so there's supposed to be some Docker configuration on this Dockerize the site part. Yeah, so all this configuration actually went to unified scaffolding repository as well. So, which on its own required to be stable. That means that every time we would touch a site or add the scaffolding files to a site, we need to make sure that it will actually work. So we had to add another CI with tests and another GitHub repository. Yeah, that's, as you can see, this is actually not the full picture. It gets a bit more complicated, but yeah, it's quite a lot of CIs here and different repositories. Yeah, so there's actually two kind of streams here going on. There's a platform and migration. So I'm just going to start on the platform. This is going to be quite interesting and simple diagram. So this stack, how does GovCMS actually run? So underneath it uses AWS, and with Kubernetes on top, with OpenShift, which is distribution of Kubernetes, and then with Lagoon controlling all that, and with Drupal then using Lagoon, or Lagoon using Drupal in this case. So that's kind of the stack. So sometimes people ask, what is actually, what is Kubernetes? Where does it run? Yeah, it runs on AWS. Yeah, that's basically the stack. Plus, yeah, it gets more complicated when it's a matter of running, 100 sites or 1,000 sites. Kubernetes handles that pretty good. I'm not going to cover Kubernetes this time, but yeah, that's it. Yeah, so that's images. That was a very interesting way we trying to describe what are the images and how many of them. And yeah, it's getting a bit crazy here. So yeah, we are using these standard Amazy.io images for different services such as PHP, Nginx, MariaDB, Solr, as you can see, Redis, Varnish. But then we needed to support multiple layers so that community can use these images for different purposes. So we have a new layer, an inheritance from Amazy images, layer for GovCMS. This is basically so that if you don't want to use any Lagoon, you can just, and you want to use the GovCMS in your own hosting, with your hosting provider, you can just use these images. They don't have any Lagoon configuration. And then another inheritance layer here is that we actually use GovCMS Lagoon, which adds Lagoon-specific configuration to allow it to run on the cluster. And then every single project has its own images that include the code and may include some additional configurations for the images. Yeah, as you can see, it's quite a lot of squares here, but they are published under different namespaces on Docker Hub, so they're quite separated. I just want to kudos to Amazy guys for the images are very stable. So we are building a very stable ground here. So this top layer is very stable. It has tests, and it's yeah, it's pretty good and convenient to use. These images themselves actually are building from official channels, as far as I understand. Yeah, yeah. So from official channels of PHP and MariaDB and Solr and Varnish. So yeah. Yeah, so the deployment pipeline is kind of simple, but at the same time very complex. So we just, for simplicity, it's basically developer would be pushing to GitLab which on its own, pushes to Lagoon, which is Amaze.io, and that pushes to OpenShift, that then schedules containers and pods and basically does provision on and rolling deployments. But that's the deployment pipeline. So every change a developer makes, goes through this process. Sorry, just one more thing. There's a link to Amaze Lagoon project, which is open source, so you can check it out. All right, so just a little bit more that we've done. We've thought about the community, how people actually going to use what we've built, because we didn't want to lock into very biased, approaches and stuff. So we try to bring the best of the breeds of technologies. So yeah, first thing is actually local development environment using Docker. So it's the same environment that is used in production and in CI. And the cool thing that we've done is we've put the tools in separate containers. So basically, once you spin up the containers locally, the whole stack locally, you already have the tools such as PHP unit, bhat. You have code linting, so some tools that you want to use for your normal development, and you can actually add your own bhat test for SaaS model, which actually very powerful. This never happened kind of before. So that's good. You can test your sites out of the box, basically. Another decision that we actually made was we needed some kind of we needed to provide Git repositories for every single site, and we were thinking how we're going to do it. So GitLab was actually the best kind of choice, because on top of everything else, it actually provided the tiered access control for agencies and vendors and Department of Finance. So we were just using GitLab groups, to properly separate the access for the repositories. Becomes very important when an agency hires a vendor, to do some work on the site, and then can easily remove it, the vendor. So that's all. So GitLab's access control is similar to how GitHub does it. So if any of you guys using GitHub organizations, that's kind of similar in a way that you just add people and remove as contributors. Also GitLab came with continuous integration in build. This is another killer feature that that we use a lot. Basically, every site gets continuous integration out of the box, meaning that there are tests that run, and continuous integration itself is a part of deployment. So deployment process. So once you push stuff to CI, push stuff to GitLab, CI picks it up, runs a build, and and if it succeeds, it actually gets pushed to deployment. I'm gonna do a small demo after this to actually demonstrate this. Also, we've got this awesome feature that we now can do branch-based development with branch-based environments supported by Lagoon. So Lagoon allows to create basically your feature branch, and then that will spin up a new instance on a custom URL, and you can just test your features separately. That just comes out of the box because of Lagoon. And we actually standardized development workflow for SaaS and PaaS. So if you know how to work with SaaS model, the PaaS model is almost the same, which is good, because agencies, the vendors that know how to do SaaS, they would know how to do PaaS. This very small but very powerful image, well, at least to me, because we have local and CI in production, they're exactly the same, meaning if you have a problem in production or in CI, you can easily produce it in local environment. So it's like, when you say, oh, but it works on my machine. So if it does work on your machine, it's actually going to work in production. Or if it doesn't, it's not going to work in production. So that, again, this is because we're using Docker Compose and Docker containers, which actually run not only local in CI, but also in production. With the with the local development environment, I don't think you should follow these links now, but basically it's a matter of setting up Docker, Pygmy, and Ahoy. Docker, we know Docker is basic, container for containers. Pygmy, something that Amaze guys developed for the resolution of DNS and some other cool things. And Ahoy is a workflow helper that just wraps some commands into easy, it's long commands into easy small commands like Ahoy up or Ahoy down. And to start a work on the project, you basically do pygmy up. What's that supposed to be? Ahoy up, sorry, Ahoy up, and Ahoy install. And that, that just installs your site locally. You don't have to do any kind of special MAMP or Acquia desktop or any kind of additional local environment software. That's all built, that's all bundled, and it's all delivered to your computer. After Ahoy install, you would have a site running. This is a very small demo. Just gonna stop it. Sorry, just a second. So this is an example of a website that is hosted on GovCMS instance of GitLab, and just showing that what kind of files there are. And basically, the important part is these themes, is where you, as a SaaS model user, you would actually be dealing with themes only. And there are some other files like Ahoy YAML and GitLab CI and Docker Compose that we provision as part of the scaffolding. And in this example, I'm just showing that you just checked it out from Git, and then you do Ahoy up, and that starts the stack of all Docker containers. It's a bit speed up because it does take a little bit time to download images and stuff, but essentially we just have this a nice stack running with all these green duns. And once you stack, you do install, and that just runs standard GovCMS profile installation, and you get this nice, and well, in this example, it's a GovCMS site itself that you get set up locally. And as part of this demonstration, as a part of development actual workflow, as a developer, you would go somewhere. Actually, right now I'm showing that this is what is from you, that URL at the top. That's what gets provisioned on Lagoon, so you have some kind of unique URL. And now we're going to do some change in CSS and commit it. And you can see that this is the local. Locally, we just changed some background, and we are pushing it up. Yeah, that's pushed. And this is the cool part that's about to start now. Yeah, so now once everything gets pushed, GitLab CI actually start to run. So GitLab starts to run your CI, and this is where you can see there is build and deploy jobs. And that basically, this is what your site would get, or any site that we migrated got. And it's a bit speed up as well, but you can see the stack starting exactly the same way on CI as you saw it locally. There's some, there'll be like some linting and some other things running here. Even this is even a behat test running. There's a behat test which passed, which basically makes a screenshot. So as a theme, as a user of this site, you can just create your own tests. And so as you can see, the deployment runs. Once this is finished, this is basically telling to Lagoon to deploy the site. Once it's finished, now the site refreshed in this environment that we saw, and we can see the change, right? I don't do the live demo of this; it's just been recorded, But you just saw that it's quite simple, and you even saw the CI and tests, and that was pretty. Well, for me, actually, as one of the team who worked on this, it was quite interesting because not everyone provides CI out of the box. It's pretty cool. So, sorry. So the platform build outcomes is, I think maybe all the time, Sorry. So it was develop platform contains necessary tools for efficiently develop, as you can see, test and deploy websites into preview and production environments into consistent and efficient ways. So basically, develop, test, and deploy websites, we have provided all the tools. And preview and production environments is something that Lagoon provides out of the box with those unique URLs, so basically per branch URLs. And consistent and efficient way, we do have CI, we do have the tests, So you can always make sure that your site is what it is, what we're saying. The migration, we have quite a lot of requirements for migration. Just want to reiterate what they were. Yeah, repeatable and reusable migrations, which must be idempotent. We had to do a scripting language, and we needed to do configuration of the sites, but also allowed to do per site alterations. And we also needed to preserve the current history, because we had, when we do migration, we don't want the development history and the Git history to be wiped out. So we needed to accommodate that somehow. And to support the future runs, we wanted to do have UI. So yeah, enter AWX. Sorry, I just have to speed up. But yeah, AWX is a tool, a front-end tool. It's a tool that has a front-end, like a UI, uses Ansible scripting language, which, for those of you who don't know what Ansible is, basically something that's used by DevOps to run scripts and provision servers. Uses some roles that has generic operations that are that work across different operation systems. But also can run bash commands if we needed to. And yeah, it allowed us to run commands on local and remote environments without too much fiddling. So yeah, Ansible does not require to have a client on a remote environment. That's actually very important. Something like Puppet would, if you know what Puppet is, would require to have a client. What that means is that we could have a new environment created on Lagoon, and without installing any additional clients, just use Ansible to SSH and do any required steps for the migration. And the configuration provided using YAML. So yeah, our migration process, and I think it's one of the last slides, this is actually the core of what we did. Prepare the assets, and then we needed to do this interesting part. So we have the sites we're running, the sites that we were migrating, we're running on the Acquia environment, in the Acquia environment, and on actually Acquia site factory, yeah. So and they had there were several modules installed actually from required by Acquia site factory. So we had to install those. We had to deal some other cleanups and sanitizations. So what that meant for us is we needed to actually provision environment exactly the same one as we would have in Acquia, to just bootstrap the Drupal and then do our cleanups, and then actually provision our own stack. So yeah, we were adding these ACSF images, provisioning the project, and then running sanitization to remove the modules and add whatever we need to add. Then we are syncing the files and replacing images to run the GovCMS images, and at the very end, we just had to make sure that every site is bootstrapped successfully. Yeah, well, that's my favorite image. Yeah, you can enjoy that. And I'm gonna step out.
Thanks, man.
Yeah.
All right, so this is going to be a bit ambitious. We're going to run through a live example of what a migration actually looked like. 1 second here, I'm just going to switch over to something different. Okay. All right, cool. So we're going to actually have a look at a live migration almost in real time. So we'll look at the end-to-end process of kicking off, migrating from Acquia all the way through to Lagoon, what the code base looks like as it steps through, and then I'll just kind of stop as we go and pull apart and show you what's happening behind the scenes. But first, I just want to take a second to acknowledge the fact that everything that you're seeing here is running on open source software. Everything from GovCMS, the work that Department of Finance have done and contributed, to AGov, the previous Next, and Acquia in the previous iteration. We're really standing on the shoulders of giants here. It would be remiss of me to not acknowledge all the hard work that people in this room have put into everything that you see here. And casting a wider net still, AWX, Ansible, GitLab, all of these technologies are really the foundation of this work. So kudos to everyone in this room and everyone contributing to the open source software. Okay, so I'm gonna have to fly through this. This is like, what we're looking at here is gonna be a 3-hour migration process condensed into like 15 minutes or so. So we'll start with AWX. This is where Toby spent hours of time clicking buttons and moving sites from point A to point B. The idea was we'd give a very simple UI with some scaffolding and kind of templates. So site templates, every single website that was on GovCMS SaaS had its own template, had its own configuration, which were those YAML values that Alex pointed at. So we'll quickly have a look at what each of those were. So first off, everything has a project name. This is just a machine name, unique identifier that we use throughout the process. So this actually forms the project name in GitLab, and it aligns to project names from the source from Acquia. We use it for internal routes and other things in Lagoon as well. So it's kind of just one of those internal identifiers for the project. Next, we provide the Git theme information. So because we're talking GovCMS SaaS, every site has its own theme that's hosted in its own separate Git repo. We provide for tags, branches, or individual commits if that's where you want to base the new project code base off. Next, we just have a couple of ACSF specific things. So the project name on the ACSF side, as well as the internal URL. So we use this for a couple of things. We actually do API lookups throughout the migration process. We annotate the migration metadata, and we kind of help piece together pieces of the migration puzzle with a couple of these Acquia APIs. And then lastly, we just need the destination GitLab information. So the group information, which is the group name and the group ID. And later on, we kind of made this one step easier by just needing the namespace, not the ID. Okay, so next up, we just go and press the launch button, and the magic happens. So I'm cheating slightly. This is actually recorded locally rather than through AWX, because it's much easier to get a full screen video. But we'll have a look here at the first step. This is the environment setup. And this isn't talking about the remote environment here. This is the environment that the migration runner is actually running all of these tasks in. Because we could run jobs in parallel, we could actually spin up containers to run multiple migrations in parallel. It needs to set these things up as though it's running for the very first time, every single time. So it needs to know about all of the SSH endpoints it's connected to. It needs to populate known hosts. We're doing Git operations, so we need to configure the local Git user. We set a bunch of migration run variables. So that is stuff like local storage on disk, file system locations, and then running through logic based on the input variables that determine a lot of the logic through that migration flow. So whether or not it's a local migration or a cloud migration. For instance, you might provide local files, a database dump, and files in a GitLab repo. So that would take a different pathway during the migration versus one that we're pulling from cloud. We also determine different Acquia hosting products, so it could be ACE or ACSF. It could even be Drupal 7 or Drupal 8. We clean the project artifacts, so every single time we run one of these processes, which we ran 3,000 odd times, I think, through that kind of warm-up phase. We clean it every single time because we obviously don't want conflicts in this process. We do drush alias generation. We do a lot of connectivity between environments, so we build those on the fly. And then we do migration tools. So because there are a lot of moving parts in one of these migrations, there's, I think, 200 odd steps throughout that cool GIF that Alex had. We've got little micro tools that help resolve some of those migration aspects. So we'll see that happening now. You can see all of those things. I'll probably fly up the screen way too quickly, but actually I don't even know if you can read that now. But it's all of that stuff. You just have to trust me. It's the Git setup, known hosts, artifact cleanup, logic checks, and that's in real time. So we're through step 1 already. That didn't take very long at all. Next, we're looking at system access check. So with those variables, we know exactly what systems we need to connect to, and we just check and validate that we can actually connect to each one of those before we proceed, because if we don't have SSH access to one of those environments, we just bail out. We also add all the project scaffolding. So those files that Alex mentioned that make up the root code base of the deployed project gets added at the step. We retrieve the source theme, so we go to that GitHub repo, we pull the theme down, or an ACE codebase. And then we do a lot of massaging of the file system. So we grab all of the Git history, all of the branches and tags. We purge redundant stuff. So in a theme, we just care about subfolders and remove the rest of the Git history. We set up a migrate folder. So we can do perpetual migrations over the same code base. We populate migrate YAML file, which contains configuration. We read in migrate customisations. So if one of these projects is run before, we actually have knowledge of the customizations that we need for each project. We annotate migration metadata, so this is where we go off to ACSF APIs. We query for things like domains associated with the website, and we populate that YAML file. Then we create the GitLab project, so we go to the GovCMS GitLab, we create the project, and there's some seriously cool magic that happens here. So the GitLab projects and Lagoon all sync. So you create a project in GitLab, a Lagoon project gets provisioned, and users and permissions kind of flow between the systems. So that happens automatically. We just verify that that Lagoon project has been created, so it's ready for us to actually deploy this, this finished code base. So then we push the code. So now we get to watch some more stuff laying up the screen. So here it's checking access to GitLab. Checking access to cloud, checking access to ACSF, and the blue ones are being skipped, so you can see the logic kind of forks off into different pathways depending on the variables that have come in. We're checking out all the branches, so obviously that can take a while depending on the theme. I can't actually see the screen, so it's hard to comment on exactly what's going on. But yeah, this is the access validation, codebase messaging, history, Git history purging, all the metadata annotation. This final step is a GraphQL query to ask Lagoon whether or not a project is available, and it is. Last step there, you can see push repo, and I think now it's waiting for 300 seconds. So at this point, we've actually got a full code base with all of the message data ready to deploy to Lagoon. We've validated that Lagoon is ready to accept the code, and we've pushed it up to GitLab. Part of the process too is actually setting up Slack notifications, so we had monitoring throughout this entire process to see where builds were. So we've got Slack notifications happening, and then we've got a code base here. So I don't know if I can pause. You can see there's locks on a lot of these files in here as well. So we're using gitlfs to lock scaffolding files, which means that you can't actually modify those files that come in from the upstream scaffold. We control those, we update those and manage those as a separate task. We've also got an example of the migrate YAML file. This is some of the metadata that we keep associated with each migration, which has stuff like domains and where the source of this migration actually came from. Okay, so here we introduced a wait time to give Lagoon some breathing space to finish a deployment, but we'll just fast forward past that and move on to the next step. Okay, step 3. So we've got an environment running in Lagoon now. It's got the code base associated with it, but it doesn't have files or database. So the next big step is really getting that cloud environment up to date. We need to get the files and database across. So some of the same steps repeated. We actually just copy some of the same drush aliases, known hosts, the stuff that we validated previously, we'll push up to the Lagoon environment. We also up the SSH keep alive because we've got very long running tasks with rsync and large databases. So now we get to watch that. So, I mean, we suffered through thousands of these, so you guys have to suffer through at least one.
It's bringing back PTSD.
This one. fun. My friends at the Department of Environment, yeah. This is actually, funny story about the last one. We got through 107 sites and the last one failed. Like, not even a lie. The last one actually failed, the only one that failed in that process. It was quite amazing, actually. Okay, so we're repeating those tasks now. We're actually connecting to Lagoon. That's why there's a slowdown in some of these commands. We connect directly to the remote environment. We add those drush aliases, the setup SSH, keep alives, make sure everything's similar to the environment we just ran the validation in. Next, we're actually going to go and dump the database. So yeah, that's what we're doing here, exporting a database. This is obviously going to take a little while. So there's one thing about the database that's interesting, actually. So we blow away the database every time we run it. We obviously ran these migrations multiple times per site. The only thing that persisted were files. So we had persistent file storage in place. So our syncs were just a differential. We weren't syncing gigabytes of file data every single time. It just meant that the final migrations were just a little differential on top of previous migration runs. Cool, so dropping the database and doing some imports. So we're doing some parallelization here as well. So database and rsyncs happen in parallel to try and get more performance across that. And we're populating the Lagoon routes. Just fast forwarded a deployment there so we don't have to watch that happen again. And I think we're close to done. So that's it. Okay, files, database are imported. We've got the files, the rsync output there. Okay, so step 4, sanitization and initial setup. So as we mentioned, we needed to actually run a lot of tasks against an ACSF-like image. So we install, first of all, the Lagoon-specific modules. But at this point, we really have a one-for-one environment identical to what's running in Acquia, or at least a close approximation. So we run those sanitization steps in the ACSF-like image, we uninstall modules, we detect whether or not Acquia Search Solr was enabled, and we swap it out for our own Solr backend. We re-index Solr. We run those per site sanitizations. So if we have sites that have their own specializations, they run here as well. And then finally, we cache clear because everyone knows that's a big part of Drupal. Okay, so now we'll watch this. This shouldn't take too long. Yeah, I did intend on talking through this stuff as it flew up the screen, but I really can't read it from this angle. You can see some of the modules coming in there, though. Redis, ClamAV, Fast404, some of those platform-specific modules, they get enabled on every single Lagoon environment, whether it's local CI or prod, so they're all consistent. We are running out of time, though, so I might just skip. It's going to do the search API re-indexing and some other bits and pieces, but you'll just have to trust me that did actually happen. And we'll go through to step 5, which is OMG, it's nearly done. So this is obviously the most exciting part of the process. We remove the ACSF Docker image that we use for that sanitization. We commit the final changes to the code base, push it up, and then we smoke test the final environment. So not a lot involved for this final step, just a bit of code base cleanup. Push the final changes up into the repository. We will skip through that reprovision so we don't have to wait. And then we wait, make sure Lagoon is ready for us. We do some smoke testing. So in this case, we're just checking the homepage for a 200 response code. We look at robots.txt because we use the robots.txt module. It's a full bootstrap. And then finally, we look for a GovCMS profile file that should exist on every single site. So it's a pretty we've got a pretty good idea at this point that we have a successful migration and everything is complete. And if we have a look, we've actually got a finished site on the other end. So the final piece of the puzzle is swapping DNS or CDN routing, and it's done. We've got a complete site. So we did that many, many times. That's not all of them. I got sick of taking screenshots. I probably should have automated that too. But at the end of the day, 108 sites, I think, came across, and yeah, it was a long weekend for Toby and the Department of Finance. Cool, so finally, just one last thing on really touching on what Alex showed you with the local dev environment. we actually take snapshots of the database every single night. There's a nightly backup stored against every single codebase's registry. That means that when you actually run those commands, pick me up, and again, I'm going to cheat by having the images local, but we'll do a pick me up, ahoy up. No need to do an install because it's actually using the existing environment. We've got a copy of the database locally. It's going to run some GovCMS deploy commands, which just make sure that our environment is identical to the deployment that would happen in Lagoon or CI. So stage file proxy, for instance, will immediately know that we're running on a local dev environment. It knows where the upstream master is, configures stage file proxy to point to prod, runs, if it was D8, runs config management imports and other exciting things. And then, having a look at one of the, this is the .n file, this configures some of the local settings, which comes for free as a part of every single project, so it's pre-configured. But if we have a look at the local URI that's configured here, then we'll see a fully functional local version of that exact website immediately available after migration. So for developers, it's obviously a powerful tool. You've got all of the CI stuff that Alex talked about. You've got immediate nightly dumps available through Docker. You're running the exact same environment that's running through CI and prod on your local environment. And yeah, that's it. 2 minutes left. Any questions?
Sorry, I just want to say just one more thing. Really want to acknowledge GovCMS team. Thank you very much. It was a really, well, firstly for being brave enough to go with this whole new thing, and secondly, it was a really pleasure to work with you. Looking at Toby here because I work with Toby. Yeah, yeah, thank you. It was a really good project, very interesting project.
Yeah, for sure.
Yeah, questions, please? Yeah.
Yeah, so the actual Drupal code base is just inherited from upstream. So it's not like every project has its own Docker image that replicates GovCMS. Just inherits the base GovCMS stuff. But each code base has its own image for the database. So that's the nightly database that gets stored. But
so, yeah, it's GovCMS is in the image, and you're sort of volume mounting the images.
yeah, exactly. Yeah, exactly. Not volume mounting the themes.
It's a layer. Basically, it's a layer on top. So you've got the base image, and you have a layer of your code on top. Okay. That becomes a new image, but it's only that.
Oh, yeah, sorry, I was talking local.
Yeah,
local environments. Yeah.
Can you show
So
the presentation?
yeah, I guess if you say upload the file through the CMS, that will change.
That's
Right.
just
But the Drupal file system is a separate persistent storage that is separate from your code.
sorry,
The
just
file system is always there. Yeah. It's just the PHP files and stuff there.
just want to show this. Sorry, just to answer the question. The GovCMS layer here has the GovCMS distribution code, which is Drupal code, inbuilt in the image. And on this layer, well, basically on this layer now, this is where we add the theme as a separate thing, right? So, yeah.
Hey, Nick. Thanks, man.
Hey, can you explain what benefits AWX brought as opposed to just running Ansible on the command line?
Yeah, so really it was just like setting up something that would allow for reusability and parallelization. So we didn't actually need to have separate containers running in across multiple nodes. We thought we might need to do this really, really rapidly and have more horsepower than a local environment could have. Plus the fact that we have revisioned log history for every single run. And then you can search across that full history. It was just a more...
But it also actually runs in the cloud, right? So I mean, it's a separate, it's a runner.
Yeah.
It's not running inside your...
Instead of running it locally, right, one by
yeah.
one, you can run it from whatever place.
Yeah. Roman.
First of all, thanks. Massively done. I know I'm sort of a bit shameless for myself being on the same team, but I guess everyone would be interested in the question about the reusability. Obviously, you base this project on a particular task of migrating from ACSF or ACE to Lagoon. How much of this stuff would be reusable for someone who is not necessarily migrating from Acquia into Lagoon?
Yeah. So we definitely thought about that, and it was built in a really generic way. So technically, there's no reason that you couldn't point it at any source Drupal project. It's really just about having drush access to a source and defining some of that metadata. So yeah, technically it would work pretty much against any source. The open source version of what you saw today, we've definitely discussed it. The Git history that we have at the moment has a lot of secret tokens and stuff in it that obviously isn't ready for public consumption. So yeah, there's definitely a plan to broaden this out to the wider community.
But we're also utilising a lot of the same processes as part of our BAU going forwards. So provisioning a new project uses the same methodology from the migration to create the GitLab repo, to bring in the scaffolding, to do the initial setup, to provision Lagoon, to trigger. So a lot of the stuff that we built as part of the migration process is making its way into our BAU, and that comes back to part of the using AWX versus Ansible. If people like me have got to use it every day, I'm going to go AWX over Ansible, but yeah, it's we wanted to make sure that the work we did in this, A, is reusable more widely, B, we can reuse it ourselves going forwards, and over the next 12 months we've got an awful lot of potential PaaS migrations to do, so building it for Acquia Cloud Enterprise and making it more scalable and more dynamic and being able to add more. We've already done some slightly crazy out there stuff. We had a couple of Drupal 8 site migrations we've managed into SaaS from it. So yeah, the value in doing the extra work up front has really paid off so far for us.